I have not created any list. I have not created any tuple with all these values. But simply I am using this range function. To this range function I am passing a value called 10. So which is a stop value. Now let us see how the output is. See, it's from 0 to 9. Okay, it generated some values from starting from 0 to 9 because we have passed the stop value as 10. So if you only pass the stop value to the range function, as I have mentioned, the start is always a default 0 and the step is always a default 1. It will keep on incrementing 1 by 1, starting from 0 till the value that we provide. Okay, so that is the range with the stop flavor. And so if you don't want to start from 0, sorry, okay, now if you don't want to start from 0, so if you want to start from some other value, okay, now let us see how can we do that. So for that we have another flavor in the range function, so to which you will pass, you will explicitly pass the start. So now this time the start, whatever you are passing, so it will pick that as a start. It won't go for the default value since you are providing some value for this start, and obviously we just need to provide a stop. So stop is like a mandatory field. Okay, it is like a compulsory parameter that we need to pass to the range function. Until unless we don't know the boundary for this range function, we don't know how many values that we are going to consider. Okay, so that is where stop is a very mandatory field or a parameter for this particular range function, and any other parameter is like an optional parameter. Here stop again being exclusive and start is inclusive. Okay, so this in the range functions or is not in the range function. So everywhere if we see some range starting from this to stopping from this, so you will obviously see start is always an inclusive value and end is always an exclusive value. Okay, not only here, we'll also see such a kind of scenarios in the range slicing functions in strings or the list. Okay, yeah, start is always inclusive, stop is always exclusive. Now I don't want to create a sequence starting from 0. Now I want to create a sequence from 2 to 9. Now what I will do, I'll simply pass some start value here. Instead of this, I'll just write another. Okay, so if I don't pass the start, we obviously know the default value for the start will be picked as 0. Now if I want to start from 2 to 9, if I want to print values from 2 to 9, yeah, I can do that. I can simply pass 2 as a start value and 10 as a stop value. So it will print values from 2 to 9.
So here the range value we can pass it as dynamic also, right?
Yeah, we can also pass it as a dynamic function. Yes, dynamic values. So for that, you just need to create some variables before start variable, stop variable, and you just need to like take them as inputs, and you can simply use those variables inside this range function. Yes, that is also possible. I can show you an example. Yeah, so this start is my variable. So since these are like integers, I'm like typecasting this int, and I'm calling the input function int at the start. And similarly stop. So now instead of these hard coded values, I am going to use my variables start and stop. Okay, yeah. So now I want to start printing the values from 3, okay, till let's say 8. That means 3 to 7. Yeah, 3, 4, 5, 6, 7. Yeah, dynamic also possible. So whatever the values that you see hard coded, so we can always use a dynamic function over there. So a dynamic input method over there. Okay. Yeah. So these are two flavors of range function. So wherein it can accept only the stop and it can accept start and stop. There is another flavor of the range function. So as I have mentioned, right? So if you don't pass a step, step is defaultly 1 in the range function. That means it will increment 1 by 1. Now if you want to change that increment, if you want like step, if you you want to hop two levels, that means 1 to 3, 3 to 5, 5 to 7, like that. So that also is possible with the range function. So now let us see the syntax for that particular flavor. So to this range function, so first value is a start, and then stop, and then the step. Okay, so now the same values apply here. Stop is an exclusive value and start is an inclusive value here as well. Okay, yes. So now let us see the syntax for this. Let me comment this out. In a similar way, so I'll also take step as input. Okay, so now, so you might be wondering, first we'll see an example like this. Okay, now I'll just wanted to start from 0 and wanted to print 2 steps ahead. I mean 0, 2, 4, 6, 8, like that. Okay, till 10. How can I do that? For range function, I'm calling the range function. So here I have the start, I have the stop, and I can provide the step whatever I am inputting. Now I'll simply print the value. Yeah, now I wanted to start from 0, stop till 10. The step, I mean I wanted to hop 2 levels. Okay, now what I have got 0, 2, 4, 6, 8. So these are the values that are printing for me. Okay, yeah. So this is how we can use this range function if you want to like create some memory efficient sequences which has a very short time span or the lifespan, I would say, and if you don't want to consume the main memory, so you can like generate a sequence of how long as you want, but not affecting the memory. Okay, so that is the beauty of this range function. This we can take it as a note. So this is an in-memory. In-memory data sequence. Okay, and does not store in the main memory. So if you are not like using the main memory, that is a very memory efficient. Okay, even it is like storing inside the memory in the cache memory, but it is not going to like stay for the very long. So once you come out of this for loop, okay, so once you come out of this for loop, and if you see inside the memory, not in the main memory, in the cache, that means RAM, so that time also it is not even available until and unless you are inside this for loop. Then only you have all this sequence inside the cache. So once you step out of this for loop, so there is no reference of this range function, and even there is no memory occupied by this range function. Okay, and you cannot like reuse this range function, the same one. So you can like again write the same syntax again, but yeah, you cannot use the data from this to again. Okay, but there is also a possibility. So you might want to like store this particular data in the main memory. So at that time, we'll see whenever we go to lists or tuples, we can simply convert these things into lists or tuples. As I have mentioned, so this is a sequence. So if it is a sequence, so it can be converted into another sequence type. Okay, but yeah, so this does not have a memory reference. If you try to print the value for this range function, you won't be able to print the values. Let me take an example for that. Let me comment this out. I just wanted to show you why this is not taking any memory. I'll simply just say a range of 10. Okay, so if this is in the memory, so whenever I call this range of 10, so it should go to the memory. We know how the flow works. It should first go to the main memory, it should first go to the cache, and from there it will fetch the reference for the main memory. It will go to the main memory with that reference and fetch whatever the data that is there in the reference memory, and just print that or paste that into the console. Okay, so that is the flow. So if we have some reference memory in the reference in the cache memory, so that means this is occupying some memory. If it is occupying some memory, so whenever I call this range of 10, so it should print whatever the values that it can have. So now if you could like print this particular range of 10, nothing got printed. So it just simply printed the same range of 0, 10. Okay, it simply stores range of 0, 10. That's it. It does not store any values. It does not store any memory reference. Okay, that is the main usage of this range function. If you want to temporarily create some sequence, okay, and if you want to use that sequence only for that purpose, then range function is a very memory efficient function which you can leverage. You don't need to like create a list, you don't need to create a tuple, or you don't need to create any other sequence for the same. Okay, so creating any sequence data type will cost for the memory. Okay, so that is some cost. It is like costing us some memory space. That's it. This range function is a very free function, so which does not occupy any memory. That is the only thing that we need to remember on this range function. Okay, it does not hold any memory inside the main memory. It can simply have this whatever the function that we have in the reference memory. So once we go out of this particular command, so it does not have any lifespan, and there are 3 flavors based upon the variables that we pass to this function: stop, start, and step. Stop being a mandatory argument that we need to pass, so we can't simply call a range function without any variable. So if you simply call a range function without any arguments, you will simply get an error, because this range function definitely needs some value where it has to stop. Okay, so from where it has to start, that is a default value that we know. It is a 0 value. It starts from 0, and if you don't provide any start and step, so it will take the default values as 0 and 1. Okay, and stop is being a mandatory argument, and start and step are like optional arguments. Okay, if you want to like change the start, if you don't want to start from 0, and if you want to start from any other value, yeah, you can include that in the input arguments. And if you also want to like include the step, how you want to hop on the data, okay, then also you can use this step. And one thing we just need to like think about is we just need to remember is this stop is an exclusive value. That means whatever the value you give for stop, so it is not printed. Okay, so it will just print till stop minus 1. That's it. And start value is always an inclusive value, so it will start from 0 and it will start stop till stop minus 1. Okay, so this is one of the very important functions, so which we can use whenever we want to create some temporary sequences. Yeah, that is why I am just introducing this function before we move on to decision making and loopings. Okay, let me know if you have any doubts on this range function or the dynamic input. Otherwise, we'll move to the decision making topic. Okay, I'll take that as an okay. See, just coming to the flow. So we have seen what are the data types. That means what kind of data that we can store, and then we saw what are all the operations that we can do on the data. Okay, so these two are completed. Now, so it is not always you want to do the same operation on all kind of data. Sometimes you have to like make some decisions, just like our real life scenarios. It is not very simple. Okay, so you have to make some decisions. So based upon the decision, the flow will vary. Let us take a database as an example. Okay, not everyone has the same access to the database. Some people has only read-only access, some people have write access, some people have admin level access. Okay, so let us just take these 3 access. Okay, in your organization, few people have only read-only access, some people have write access, some people have admin access. So based upon the user who is coming into the database, you need to make a decision. So which access you need to provide for that particular user. At that time, we need to make some decision, right? So how can we make a decision in a programming language? So we know in a real life we can simply say, okay, this person, he is from the DB administration team. Okay, he should definitely have an admin level access. Oh, he is a developer but not from the same thing. He should have a read only access. Oh, he is a developer from the same thing. He should have read and write access. So in a real life we can simply say, but in programming language, how can we tell the machine that, so to which user you have to provide which access? So how do you take a decision in a program itself based upon the input that is coming? Okay, so that decisions, this is not very new to the Python. This is being like started from the C language itself. This decision making can be achieved using the if else. Okay, if this, then do this, else do this. Okay, just like our real life scenarios. If he is from the database team, then allow access. If he is from the same team, just allow read access, write access. That's it. Just like we say, the same thing can be achieved in the programming language, but the syntax vary in different programming languages. Okay, so in C we have a different syntax, and in C++ we have a different syntax. In Java we have different, and in Python also we do have a different syntax to achieve the same. Okay, but yeah, we can achieve the same thing in any other programming language. So these are the basic features which are available in any programming language. Okay, in any programming language, if you were to use, so you should be taking some decisions. So if you were to take some decisions, you need to like communicate the same to the machine. If you want to communicate the same to the machine, there should be some syntax inside the programming language. So that is our if. Okay, so now we understood how why we need to make some decisions. So this is one simple example that I have given. So there can be multiple examples. Okay, like sometimes you might be like seeing session timeouts. Okay, so it will keep on checking. Let's say you have started at 10 o'clock. Let's say for this portal we have only 5 minutes of expiry time. Okay, it can only like stay online for 5 minutes. Okay, just after 5 minutes it will simply auto closes. So for that also it will simply keep on checking. If time is like 5, if time is 5 minutes, if time is 5 minutes, if time elapsed is 5 minutes, it will simply check on that thing. So until we arrive that particular condition, that means that the time elapsed is 5 minutes, we simply close the connection. That's it. So these are simply few examples, but yeah, we rigorously use these decision makings in every way because that is how the business logic works. Okay, now we have seen how do we make the decisions and what are the scenarios where we need to make a decision. But yeah, how can we achieve the same in Python? Okay, or is it very similar to any other programming language, or is it some different? Does it have some different syntax? Yes, it does have some different syntax compared to any other programming language. Okay. Let me take in. So our next topic is the decision making. Okay, so what it does is it helps the programmer, or I would say machine, okay, so this is very programmatical definition. Okay, so we do have some different blocks of codes or suits of code. So if some condition is like satisfying, we wanted to like execute some piece of code. If another condition is executing, we just wanted to execute some other lines of code. That's it. So it just helps the machine or programmer to make some decisions. So based on the output for the decision, it just executes different blocks of code. It is like that only. Yes. So I just mentioned if. So there are 4 flavors again. First flavor is if. Okay, if there is only one condition. Okay, sometimes let's say there are some exceptional conditions. When I say exceptional condition, that means there is, if the condition is like satisfying, then you just provide that thing. Otherwise, you don't even worry about that. One such example is, let's say if you want to like check if the number entered by some user is 0 or not. Okay, at that time you just simply check if the number is 0, that's it. You don't want to like check another thing. If the number is 0, then print the value. Otherwise, you don't need to do anything. The problem statement itself says if the number is 0, then print it. Otherwise, don't do that. Okay, at that point of time we just need to we can simply use the if. And if the problem statement says if something is true, then do this, otherwise else, then do this. That means here in the statement itself we have one if, one else. That means we have two blocks of code. If the condition is satisfying, then execute a block of code under the if. If the condition is not satisfying, then execute the block of code under the else. So here the combination is if else. That means there are only two conditions. Okay, if there is only one condition, then we'll use only if. If there are two conditions, we use if else. And if there are multiple conditions, okay, it is not only possible that we have always one or two conditions. So there can be like multiple conditions. Let's say if you were to grade some user, okay, based upon his marks. A grading system, let's say in a school, if you want to like build a design a grading system, so based upon the student marks, let's say if he achieved more than 90, so we just need to provide A. If more than 80, B, 70, C, like that. Okay, so in that point of time, so we have multiple conditions to handle. So at that time we have if, elif. So elif is a short term in Python for else if. So in any other programming language we call that as else if. Okay, the combination of both the words. And in Python we shorten that particular two words into elif. El from else and if from if. Okay, and finally our else block. So if we have, none of the conditions is satisfying, then we simply fall back to the else. And yeah, these are some simple things on if else. So there can be possibility. So you made some decision, okay, but yeah, inside the decision you also wanted to make another decision, and inside that decision you also wanted to make another decision. That means one after the other you are making decisions, not sequentially, but at the same on the same decision itself. If something is satisfying, then check this. If that is also satisfying, then check this. So this is going like a nested thing. So that thing we call it as nested if. Nested if. And again in the nested if also we can always use all these scenarios. If else, if else. Okay, yeah, but yeah, so having more nested ifs is not a better practice. Okay, so it will like maybe for today, if you are like developing the code and all the people in your team knows what you are like writing, in future your code might have gone into a maintenance mode. That means everything is working, but in future something might have happened. Okay, but none of the team members who were there during the development are present in the same firm when we had some issue with this maintenance code. At that time a new person came, so we know how the production issues work. We just need to resolve the production issues as soon as possible. Okay, at that time, so if you were to like give this nested ifs more than like 2 or 3 levels, so it makes the developer who is like working on that time, okay, who don't even know what is happening inside the code, he has to go through this particular code. And if you are given more than 3 nested levels, so it is very confusing to that particular developer to arrive what exactly we are doing. So in a better programming things, in a better programming practice, we don't go beyond 2 or 3 levels of nested ifs. So if we are going that level, so we just need to find some efficient way to combine all these conditions into one simple condition, or at max 2 conditions. Okay, yeah, so yeah, don't go beyond 3 levels. 3 is also like at maximum. If you are not able to like filter it out to your 2 conditions, yeah, then go to the 3 nested ifs. Otherwise just limit yourselves to the 2 only. This is just an advice, but yeah, it can vary with teams and organizations. Okay, at max 3 levels. Okay, the third level is also if you are not able to come into an efficient way of two conditions, then only go for the third level. Otherwise, just limit yourself to have only two levels of nesting. Okay, yeah, even for the loops as well. So we also have this nesting topic in the loops. Don't go beyond two levels of nesting anywhere, even if it is like conditions or even if it is looping. Don't go beyond two nestings. Yeah. Okay, now we'll see examples for this. Before looking at the examples, we'll just see the syntaxes. Syntax is very simple because we know Python is very easy. It has a very easy syntax. What we just need to use, if we were to use only the if, that is if keyword, okay, just after the if keyword, you just need to provide some condition. So it is not necessary that you need to provide the condition inside the circular basis. But if you have more than two conditions, I mean, if you are like using any logical operator or any other operator, yeah, more than one condition, yeah, it is advisable to enclose them in a circular basis. Okay, that provides better readability. Again, it is a better practice, and it is up to you. If you want to use this circular basis, yeah, you can use. Otherwise, it is up to you. Okay, but yeah, ideally, if you are like having more than one condition, it is advisable to have circular basis. Okay, and once after you have this condition, then you can simply use this colon. Okay, now you have the if keyword, and after the if keyword you have a space, and then we have the condition. If there is only one condition, you can simply give that condition without any braces. And if it is like expanding more than one condition, just enclose them in circular basis. And yeah, just after closing the circular basis, just give a colon, and after the colon, when you click on enter, Python compiler will automatically understands, okay, the user is creating another indentation. That means whenever you click on enter, so it will start a different indentation level. Okay, in Python, the different indentation level means it is a different set of code. It is falling under different tree, I would say. Okay, Python execution happen in a hierarchical manner. I will explain that with an example. Okay, but yeah, let us see the syntax for this. So this is simple. It's syntax. Okay, if you want to like write an else, you can simply write an else and a colon. Colon is compulsory. I'm sorry, I'll just leave it as colon. It is going by some values. Okay, now you just need to give a colon and then enter. And if you were to use this elif, yeah, it comes between if and else. Okay, if you give elif after the else, it throw an error and it is not even useful. Okay, elif command between these two. But yeah, just like if, so whenever you see if, you need to provide some condition, but for else you don't need to provide a condition. So here in elif also we have if, that is where we just need to provide some conditions. That's it. Okay, so this is very much syntax of how we use the if else, and along with this elif. Okay, so whenever you use elif, so some people call it as if ladder. Okay, instead of elif we can call it if. Someone says write an if ladder, else if ladder, that means they are referring to the elif only. Okay, because we have multiple conditions and we are simply using if, elif and else. So that is like a kind of a ladder. So that is true. So like just a ladder, just take a ladder as an example. If you step on the first step, yeah, then true, then go for the second. It is like that. So till you like if you were to like hold something, just like climbing the ladder, it is just comparing the ladder with the if. So if first condition is true, then okay, otherwise go to the second, otherwise third, fourth, fifth, sixth, and ultimately fall back to else. That's it. So this is the syntax for if and else. Now let us take let me like walk you through examples for this. Okay, simply with if else, if else, how they will be useful. Okay, with some problem statements. Now the first problem statement is so in some question, okay, so let's say we have a question, input an integer, that means take an integer as input and okay. So here the problem statement is some user is asking us, so if the take some integer as input, okay, and if that integer is positive, then just print if, okay. So nothing is just adding to this condition. If the number is positive, then only yes. So we don't have any else coming into the question. That means here we know that we just need to only use if. That's it. Now let me take an integer as input. I1, let me call it as I1. So we know first we need to use an input function. This is not a code block. Okay, so now I need to use I1. I'm calling an input function. Enter the integer. And we know the question is he is asking us to take integer as input, but when I simply use the input function, it will simply return a string, and I am not able to even check that whether it is a proper positive value or not. Okay, at that time what we need to do, we need to explicitly cast this input, I mean string input, to an int input. That is where I am using the int function for typecasting. Okay, now I have I1 as integer. Now I just need to check if. So now I have only one condition, right? So I just need to check if this positive. Positive means it is greater than 0. I1 is greater than 0. That means, so this is my condition. So my condition is over, and I just need to use a colon. So far if you could see, all the indentations are this. So this is one level ahead. Now whenever I click and enter on from here, okay, so now the hierarchy goes one level downwards. Previously all the parents, I mean all the initial commands are starting from here. Okay, now whenever you are like about to start some another piece of code or some other block, we simply say that as a suite of code. Okay, so that suite, if you were to like start a suite just like in if or for loop or in a function, that will go one level downside from the parent hierarchy. Okay, so it will just build a hierarchy. First this if is at the parent level, and whatever the block of code that is under the if, so that goes to the child of this if. Okay, and if you were to go back to the parent, again you need to press a backspace and just go back to the same. We'll see how that is. So now whatever I write here, so it will simply under the if branch only. Okay, I just need to print yes. So this was the problem statement, right? So take an integer as input. Okay, the first step is done. And then the second step, what they are asking us is, so if the number is positive, then just print it. Print it as S. Okay, so that is what I am doing. I am just checking the number is positive, then I am just printing S. Okay, so this particular statement is under if hierarchy, but this if is at the parent hierarchy. Okay, yeah. So now if I click enter here, so it will be still under the if hierarchy. If you want to go back to the parent hierarchy, that means the main indentation, you just need to go a backspace. So that is where we are at the same level of if. Okay, so whenever you are dealing with Python, you should be very sure about these indentations. Okay, so when you start a new level of indentation, you should be very sure that you should come out of this, that indentation and start your main code. Okay, just don't think that Python will automatically handle this, because in Python we don't have a delimiter. Okay, in any other programming language, if you have some touch on any other programming language, semicolon is used as a delimiter. If the compiler encounters a semicolon in any statement, so that will think that okay, this colon is coming here, that means this is the end of this particular statement. So whatever the next statement is coming in, it will automatically go there. But in Python we don't have such a kind of delimiters, so it is only the indentation which delimits what is where this block of code belongs to. Okay, yeah, like this. Now let me simply run this simple piece of code. I simply give 10 as input. Since 10 is a positive number, I will just simply print yes. Okay, that is what the question is. Now they don't really talk about the negative number. How can we handle the negative number or a 0? Now let me give a negative number -1. Nothing got printed because that is what the question is. So we just need to take an integer as input and we just need to print s if that number is input. Sorry, if that number is positive. That's it. So that is why we just need to use if. But yeah, if the question says the question. So previously the question was this. If the number is positive, then print yes. Okay. Now what I'm doing, I'm like extending this question. Okay. Else print no. Okay. So now they are telling, so if the number is positive, we just need to print yes. And if the number is not positive, that means it can be negative number or it can be 0. So in both the cases, what we need to do, we need to print no. That's it. Okay. Now let us see. We already have a positive condition. Okay. Now what we need to do, we just need to fall back. That's it. Okay. It is simply fall backing on. That's it. Other than this condition, we don't have any other condition. See, what is the condition? If the number is positive, that is the only condition we could see. And otherwise, if the number is not positive, we just need to fall back to this printer. No, that's it. That is where we just need to use the else. So if you were to give the else, so else should be at the main indentation level. That means you need to go one level behind and write your else. As I have mentioned, else does not take any condition. Simply else keyword and the colon and then enter. Okay, here we just need to print no. That's it. Okay, now if I give negative number as input, so it will simply print no. Okay, so previously it was not printing because that was the problem statement then. Now they have like extended the problem statement. If the number is positive, then we just need to print yes. Otherwise, we just need to print no here. Okay, so this is the problem statements and this is how we use if and else based upon our problem statement. Okay, now let us see how can we use this elif ladder. Now instead of this fallback mechanism, now what they are doing is, so they are extending the question again. Okay, else if the number is negative, print no. Okay, else 0. Now the problem statement has changed. Now the question is, so if the number is positive, we just need to print yes. And also we have another condition coming in the question. So if the number is negative, okay, else if the number is negative, then print no. We have another condition. So first condition is the number is greater than 0, we just need to print positive. And if the number is less than 0, we just need to print negative. And we have a fallback mechanism. We just need to print 0 if none of the above two conditions are satisfied. Okay, now let us see how can we do that. Maybe no, we just need to use elif. That's it. Elif. So as I have mentioned, so here I have if. That means I need to provide some condition. So what is the condition? So in the problem statement itself, we have a condition. Number is negative. That means we just need to check if I1 is less than 0. At that time, we just need to print no. Okay, this is if. This is elif. And we have one fallback. What is else? And in the else block, we just need to print 0. That's it. So this is how I use if, elif, else. That's it. Now let me give a positive number of 10. Okay, yes. So see, let us like go line by line. First, I have given 10 as an input for this I1. Now first it will come to this first if statement. Okay, it will check this condition. I1 is greater than 0. This is a comparison operator. So we know what is the output of the comparison operator. It's boolean, true or false. Okay, So here I1 holds a value of 10. 10 is greater than 0. So this comparison is true. 10 is obviously greater than 0. So since this condition is true, that means what this if does is, so it will take the cursor to inside it. So whatever the block of code that is inside this if, it will simply execute. Okay, so that is why it's simply printed yes for us. And so since this condition is true, so Python compiler what it does is, so one of the conditions inside this ladder is true. That means it simply go outside of this complete ladder. It doesn't check for any other further things. Okay, so that is why it is called a ladder. It will check one. Okay, so are you like achieving the goal for the first step? Okay, if you are achieving, then yeah, okay, fine, then leave from the ladder. Otherwise, then go one step ahead. And if you are not achieving there, then just go one step ahead. Not there, just go one step ahead. It is like climbing a ladder until you achieve the goal. Okay, otherwise we have a fallback mechanism. So if the cursor reaches still here, that means none of the conditions above are satisfied. Okay, so none of the steps before this fallback are satisfied. That is why it entered into the fallback else, and whatever it is inside this else, it just printed. Okay, yeah. So now first we are in the first step of this ladder. Okay, it simply checked whether 10 is greater than 0. Yes, true. Okay, that is when it entered into this particular block of code, printed yes. That is why it did not even go into all these blocks. Okay, now let me give a negative number, minus 12. See here the same thing happens. So first it will check the first step. If minus 12 is greater than 0, this comparison is very false. That is where this false. That means this step is not satisfying the condition. So next it will go to the next step. So in this step, so minus 12 is less than 0. Yes, true. So this step is satisfied. The condition for this step is satisfied though. That's why it just printed the no on the console. Okay, and it does not even go into the fallback mechanism because one of the step already satisfied. Now coming to the 0 condition, which is the fallback. 0. Now see, 0 is greater than 0, false. The condition for this first step is false. We need to go to the second step. Okay, 0 is less than 0, again false. It will go to the fallback mechanism directly. Okay, yeah, like this. So like this we use this if, else, and in between you can add multiple else if your problem statements says so. Okay, in your problem statements if you have else if coming many times, it cannot be like literally else if, yeah, but it is our responsibility to decode the problem statement. In the problem statement they don't really mention the problem very explicitly. That means in a very simple terms which we can understand. It is our thing, it is our problem solving skills which we need to derive, which we need to convert the problem statement into our understandable language. Okay, and from that only we can take that to machine understandable language. Okay, yeah. So yeah, they don't really mention whether it is elif or if or else. Okay, it is us who should decode the problem statement into whether we can use this if and else ladder or not. So this is the ladder for us. So any doubts so far? Okay. Now let us go for the nested ifs. Nested is nothing but, so I just mentioned, right? So inside an if we'll have another set of this if, else, if or else. So you can have many of this. That means just we have one if, inside it we have another if, inside that we can have another if. That's it. Okay. So now I'll just give one problem statement. So I have like two values. Okay, I'll just you will be like taking two values as input. Okay, let's say x and y. We just need to like check if x is greater than y. If x is greater than y, then we just need to check whether if x is positive, then we just need to print that as positive. Otherwise, we just need to print it is as negative. Okay, like that. The problem statement is okay. Yeah. So now this is the question. So here they are asking us to take two integers as input, and the question is check if the first integer is greater than the integer is greater than the second one, and print positive if the first element is positive or else negative, and vice versa. Okay, here we need to make two comparisons. Okay, first we need to check whether the first value is greater than the second value or the vice versa, and then in the second set of if conditions, what we need to check if that number is, if the greater value is positive or negative. That's it. Okay, so for that we need to take inputs, right? First we need to take input. Let me say x as an input. Okay, now I have two integers taken as input. So the first step of this problem is completed. Now next, what I need to do, I need to check whether the first element is greater than second element or second element is greater than first element. So first I need to check one condition. If x is greater than y, okay, if this is true, okay, that means x is really greater than y. Otherwise, obviously y is less than x, right? It can be like x is equal to y, but let us like not consider that particular case. Okay, same, let's take two integers as input. Yeah, the question is take two non-equal integers as input. That means x and y can never be same. And yeah, coming to this if condition. So first we are checking if x is greater than y. If this is true, then it will simply go into this if condition. Okay, otherwise we have a fallback. Just let me write a fallback. It will go into an else block. That's it. I have the main skeleton. Okay, if x is greater than y, it will go into the if block. Otherwise it will directly fall back to the else. It will defaultly consider it as y is greater than x, because in the question itself they are telling x is not equal to y. Okay, so this is the first if level. Okay, now in the second level, what we need to do, we need to check the greater value. What is the greater value in the if condition? X is the greater value. We need to check if the x is positive value, then we just need to print positive. Otherwise we just need to print not positive. Okay, here I need to check if x is greater than 0. I'll simply say positive, and they did not give any condition for the for any other condition, so they simply just falling back to not positive. I can simply give else. That's it. So this is what we just need to do. So if x is greater than 0, we just need to we just need to print if positive. Otherwise we just need to print not positive. Okay, for our sake we say x is positive, x is not positive. Okay, now in the if else, in the main else. Okay, so inside is this else, when the cursor comes is x is less than y, that means y is greater than x. So here we just need to put the condition on y. If y is greater than 0, y is positive. Now I have the fallback. It's y is not positive. So this is a nested if. So inside this if we have an else if else, and again inside this else we have another if else. So this is what we call nested if else. Okay, so this can not go beyond 3 levels. It is up to us. Okay, so if we go beyond this, it is not advisable. And yeah, if it is going beyond that, yeah, we can like check for a midway, so where we can achieve whether with the 2 conditions or 3 conditions, whether we can combine the conditions or not. Okay, yeah, so this is how this nested if is done. Let us see how the execution happens. Now let me give x as 12 and y as 9. Now the value is x is positive. Now let us see how this particular statement is printed. Now see, for x we have 12 and for y we have 9. Okay, these are like stored inside the memory. Now whenever I am doing this condition on this for the if, checking x is greater than y. So here I am doing a comparison operator between x and y. So 12 is greater than y, which is obviously true. That is where this if condition is satisfied. So now the cursor go inside this if condition. Okay, so now it will check for this if else. Excuse me. So now it will check for this if else. Now we encountered again an if here. So here we are checking only for the x. So here again and comparison operator is x greater than 0. 12 is greater than 0, which is true. That is why we got x is positive. That means we only printed this. The cursor only executed this many lines only 3 lines. Because the first condition in the main if is satisfied, and the first condition in the nested if also satisfied. That is why it is it did not enter into any other else's. Okay. Now let me give some negative values. Yeah. See. So for the x, I have given minus 12 as input, and for y, I have given minus 9 as input. Let us go for the conditions one by one. So for the first main hierarchy, which is the first level of if. So here we are checking if x is greater than 9, y. That means minus 12 is greater than minus 9, which is false, because minus 12 is less than minus 9. So the cursor does not go inside this if. Okay. So now we have an else. That means we have a fallback. We don't even check for any other condition. If the cursor come till else, that means it obviously execute whatever we have inside the else. Okay. Now here, without checking any condition, it will simply go inside this else. Sorry. Now inside this else, we have one condition first. If y is greater than 0, minus 9. Minus 9 is greater than 0, which is false. That is why the cursor did not go inside this if. Okay, it fall back into this else. That is why we got y is not positive printed. Okay. Now, are we clear with this? Let me know if there is any confusion or not able to understand at any point. Okay. Now, I would like to give the same question as a practice. Okay. So this is the practice problem. So I just want you to achieve this nested if using the elif ladder. Okay. Yeah, it is up to you how you like how you want to achieve this particular thing with the elif. Okay. Now we are like done with the decision making. Yeah, let me know if you have any doubts. Otherwise, we'll enter into the loops. And yeah, at the end of this session, so after we complete this session, I'll just post a few problems in the group based upon whatever we have seen today. Yeah, so let's practice them. You'll only get a grip on this. Okay. Now let me move on to another topic. Looping. So now we know how to make a decision and how to act based upon the output from that particular decision. There can be scenarios we might need to execute same piece of code or block of code multiple times, okay, based upon a condition. Okay, so if this condition is satisfying, that means a piece of code we just wanted to execute that repetitively until we achieve a base condition. Okay, so at that scenarios, how can we achieve? Okay, and again, this looping is not a very new topic in Python. This is a very basic topic of any other programming language, just that the syntax varies with the programming languages. So if you were to like execute, same code multiple times, yeah, we can leverage this looping structures. Okay, and this actually promotes reusability. Obviously, because see, let's say if you were to like do this x is, let's say we don't have only two variables. Let's say we have two lists. X is a list. In that list we have like 10 values, and in the y list we have 10 values. So if you were to like compare each value, first value with first value, second value with second value, third with third. So you can't simply write 10 such a kind of statements, right? Okay, so we can simply write a loop on this particular list. Okay, and we can simply have this particular code inside this loop. That's it. So based upon the input that we are getting from the loop, we can simply perform this action multiple times. Okay, this promotes the reusability. That means same piece of code we are like reusing for different set of input. That's it. We are not like writing the same code multiple times. Okay, it is simply waste of time, and we don't even know how many times we want to execute this particular thing. So let's say, but today we have the size of this list x as 10 and size of list y as 10. Okay, but in future, let's say the size of this grows to 100. At that time, we can't simply like copy paste this to 100 times, right? Okay, at that time we can simply use this looping structure, so which promotes the reusability of the same piece of code can be executed for different inputs. Okay, until we achieve some base condition. Okay, this base condition is very important, because if we don't achieve this base condition, this loops enter into an infinite loop. Okay, considering it won't even stop. It will keep on running until and unless your memory itself will crash. Okay, it won't stop. So that is why it is very important whenever we are dealing with the loops or even recursions. Recursion is also another kind of looping structure that we'll see in the functions. Okay, whenever we are dealing with loops or recursions, it is the first responsibility to check what is the base condition. That means way to stop this loop or way to stop the recursion. Okay, until unless you don't find the stop for this too, so this enter into an infinite loop, resulting in crashing of your application. Okay, so yeah, if you were to like execute the same block of code multiple times, yeah, we can like use this looping structures. There are mainly like two looping topics or two structures, I would say, in Python. Okay, for a while. In another programming language we do have do while, but here in Python we don't have that do while. Okay, we only have for and while, and there are some differences between for and while. Yeah, before going into the looping structures, I just wanted to like explain three different clauses. Okay, so for loops, excuse me. So in order to execute a loop, so we just need to know three things first. Okay, so that we call it as clauses. In any programming language, so these three clauses are very necessary. Okay, so at some time, mostly for the for loops. Okay, so for loops are like very optimized looping structures, I would say, in any other programming language. So these clauses are internally handled. Okay, so we have a basic structure for loop. Yeah, but along with that, we have an optimized for loop. Okay, so in which few of the classes are automatically handled by the programming language itself. We don't need to provide them. Okay, yeah. So coming to the clauses. So first class. So if you were to start a loop, we should know, right, from where we need to start. Okay. So if you were to like move on a circle, okay, from where you want to like start and moving on this circle, okay, you should know that we call it as an initialization class. Okay, initialization class. That is fine. Now, and the next thing is you need to have a conditional class. So you have like completed one round, okay, and you need to check whether you can like go for the second round or not in the same ring. Okay, so at that time you need to like have one condition. Okay, so the output of that condition, whether if it is true, that means you are like good to go for the second round, I mean for the second loop. Okay, if the condition results in a false, that means okay, here itself we are ending. Hmm? That is the conditional clause. Okay, so this is what very important. Okay, in the loop. So until unless you don't provide a proper condition, so it will go on running into the same loop. And at the same time, in the loop, so there should be some incrementing or decrementing happening. So if you are like running in the loop, so you know where to start. Okay, you know when to like stop. Okay, where to stop, where to end. That is fine. And how do you like progress? Okay, so in every loop, let's say in the first loop you have like initially it started from 1. Okay, now then check 2 whether you are like proceeding for the 2 or not. So that is the condition. So if you are checking for the 2, how do you know whether it is a 2 or not? Who is the person who is tracking that increment? Okay, there should be some person, or it should be you, who is tracking that increment happening. Okay, you are starting from on the loop. Okay, you have started from there, from point A, and you completed one circle and reached that A, and there should be some other person, or it should be you, who should be like tracking how many rounds that you are doing. Okay, if you don't know how many rounds that you are doing, how can you apply the condition? Okay, that means in the initialization class you have this count as 1. Let's say that count as 1, and after the first round, if it is still 1, that means no one has counted your thing. Okay, no one has counted that you have like completed one loop. That means it is still 1, and the condition is still satisfied. Then again you go for the second loop. No one is counting. It is still 1. Even though you have completed 2 loops, it is still 1. That means it is always 1. The condition is not satisfying. That means you are simply running into the same loop until and unless either you would drain your complete energy, or in the programming language, if you drain the complete memory of the system. Okay, that is where it is very important to maintain a counter. Okay, so which tracks whether you are properly incrementing or if you are properly decrementing. Okay, so that we should know. That is why this conditional class along with the incremental or decremental class. Incremental or decremental class. Okay, so there should be some counter, or there should be something which should be incrementing or decrementing. Okay, based upon the condition. Let's say if you are going in a forward direction, that should be an incrementation. If you are going from a backward direction, that means if you want like only achieve 10 loops, that means you start from the 10. Okay, first if you complete 10, then the counter will be reduced to 9 until unless you reach to 0 or 1. Okay, and in the increment you start from 1 to 10. It is your implementation thing. That's it, whether you go by the incrementation or the decrementation. Okay, so these two things are very important, because if you don't handle these two things properly, especially this incrementation and decrementation class, okay, you might enter into an infinite loop, and it is not very advisable. in any application or in any programming language to have an infinite loop. And in the recent times, we have some plugins or some features which detects this infinite loops. Okay. Yep. Based upon these three, so where these three are sitting inside the looping structure, so the loops will be there. So for loop, we have a different set of these three, and for while loop, we have a different set of these three. Okay. So now let us see a while loop. Okay. I'm not going by the for loop because I told you for loop is a very optimized loop looping structure starting from C++, Java and Python. In Python it is even like further optimized. We don't even have all these classes. Okay, it is the Python compiler itself will check all these classes. It is not our responsibility. Okay, Python for loop never enter into an infinite loop. Okay, even if you recklessly write your code for the for loop, Python loop will never enter into an infinite loop. Okay, but yeah, Python while loop can enter into an infinite loop. That I will explain. Yeah. Now let us go for the syntax for while loop. So for the while loop, so this initialization class is the first thing. First we need to like initialize some variable. From where you want to start. Okay, it can be in a forward direction, it can be in a backward direction. So if you want to start from 0, yeah, you can like initialize your variable as 0, and if you want to start from the backwards, you can like initialize your variable as 10. Okay, and now you have a variable initialized. That means there is an initializer already available in the memory. Now what you need to do, we have this while keyword. Okay, while keyword, you can simply provide this condition. Okay, and just after the condition a colon. Okay, and after the colon, whenever you enter, so you will go into this. Okay, this condition is the conditional class, the second one. First initialization class and then the conditional class, and then okay, and then in the while block of code itself, you need to provide increment or decremental class. Okay, this increment or decrement should happen on this counter, this initialized variable. So most of the times whenever we are dealing with the loops, we call that as counter. Okay, yeah, whenever I say counter in any while loop or any other loop, don't like confuse. Counter means whatever the variable that we are like counting. Okay, and this increment or decrement should always happen on this counter, so which is a part of this condition. Okay, all these three clauses should happen on a single variable. Okay, it is not like necessary, but at least this counter should be part of all these. If it is not only that particular variable, but it should be part of all these three things: initialization, conditional, and the increment or decrement. Now let us see an example. Now I want to print integers from 1 to 10. Okay, now what I will do, I will initialize one variable w1. Okay, now initialization is done. I just want to print from 1 to 10. That is why I am starting from 1. Now I will start my while loop. Okay, now the condition, what is this? The condition, I just want to print 1 to 10. Okay, until 10. That means I just want to print 10 as well. W1 should be less than or equal to 10. Okay, so that is my condition. Okay, my condition is over. So I have like started my counter. Okay, I have like put some condition on the counter. W1 should be less than or equal to 10. And now what I need to do, I need to print W1. Okay, so now my code is completed. Now if I run this, are we good to run this? No, we are not at all good to run this, because see, we haven't provided any increment or decrement. That is why it went into an infinite loop. So it is still running. So printing from 1 to 10, it is very simple. It can happen in like milliseconds, but it is still running because we have not included this increment or decremental class here. So that is why it is still running, and it is still printing only 1, because no one is counting, no one is incrementing this value. Now we just need to increment this value. That is where whenever you are dealing with the while loops, it is very important to have this increment or decrement. Okay, there are very many chances that we might ignore. Let's say here this while loop expands for only 2 lines. Okay, here if you like forget this thing, it is really a problem. But yeah, sometimes our while loop may extend for 50 lines, 60 lines. It is quite a possibility that we might miss this increment or decrement class. So at that time, this will enter into an infinite loop. That is why whenever you are using a while loop, you should always, whether your while loop extends for thousands of lines or hundreds of lines, it doesn't matter. If you are using a while loop, you should always check whether you are incrementing or decrementing the variable. Okay, otherwise don't use a while loop. It is advisable to use a for loop. Okay, because for loop is very optimized. It can handle the infinite loops. Okay, wherein while loop there are many chances that a programmer may slip this particular third class, which is very important for this while loop. If you don't give this class, we saw this, right? So it just enter into an infinite loop. Okay. Now what I will do, I'll just increment this. I can do it like this, incrementation. So I'm just incrementing one by one. But yeah, so this is not a very good way to increment. We know how this addition assignment happens. So I'll just simply go for the addition assignment. Okay. Yeah. Now we know what is the difference between the previous statement and this statement. We already seen that in the operations. So which one is like pretty faster? My parent, so it's simply printed from 1 to 10. That's it. So yeah, don't forget about only caution that I can give you is whenever you are like handling this while loops, just handle them very gracefully. Gracefully in the sense you should always have this incrementation or decrementation. And one more thing. So here I have given the incrementation. So let's say I have written this 100 lines of code, but I forgot. It is quite a possibility. I forgot whether to give an incrementation or decrementation. I simply give a decrementation. That means this value will go just below 0, below 1 only. That means all the negative numbers. That means it is always less than 10. See, in that case also, it will enter into an infinite loop. See, it's simply printing all the numbers still infinite. Okay, that is why. So whenever you are like handling, whether if you are going in the forward direction, just have a incrementation. If you are going in a negative direction, I mean in the backward direction, just give a decrement. Okay, now if you were to like print values from 10 to 1, now the initialization would be 10, and you just need to check if the number is greater than or equal to 1. Okay, now since we are going backward, that means 10 to 1, so here a decrementation would be very much helpful. Okay, here if you use an incrementation, it is not a real thing. It will enter into an infinite loop. Okay, yeah. So whenever we are dealing with this while loop, okay, we should always be sure that we should always include this increment or decrementer class. And if you are not sure, just go for the for loop. Okay, so that is why people don't really use while loops. I would say that until unless there is a specific use case in Python. The specific use case in Python is whenever you want to iterate, whenever you want to do a loop, okay, not on a sequence. At that time, you can use a while loop, because a for loop can handle the sequences or the iterables very gracefully than a while loop. For the while loop, you should always give this initialization class, conditional class, and the increment or decremental class. Now, so this is a very for loop, by a very while loop. There is one beauty of while loop in Python. Okay, this is not available in any other programming language. So a while loop can also be clubbed with an else. Okay, yeah. So this else, this is very much similar to if else only. Okay, so if this condition, whenever this condition returns a false, that means it is not going into the while loop. It will simply go to the else. At that time, we can simply use else. If you were to give some meaningful information, let's say you have like finished this particular loop, then you can simply want to let the user know else. You can simply print some statement here or do something, okay, like that. So now here what I can do, so once printing all these values is done, what I will do, I'll simply print end, okay, yes, end. Why this else is sometimes useful is, so here we know these are hard coded values, this is 10, this is 1, okay, at that time we know, so this obviously will go into this value. But yeah, whenever the user input value, that means the dynamic data is coming in, that times we don't know what is the data over there. That time if we were to check whether this particular data entered into this loop or not, let's say the user might have entered 0, okay, so 0 is never greater than or equal to 1, that means it don't even go into this while loop. At that time if we just run this, let me just run without this first, okay, if I run this, okay, the user has entered 0, okay, nothing got printed on the console. There is a quite possibility, there are two possibilities here, either the user has entered a wrong data or there is something happening in our application wrongly, okay. So if you were to know exactly what is the reason, so whether the user has entered some wrong data or the application went horribly wrong, so at that time, so whenever we use this else, we can also handle this in different ways, but yeah, so this is a very simple thing we can use. Okay, now see, it simply printed end, that means okay, it checked for this while loop, that means the cursor has come to this while loop, but yeah, the condition is not satisfying, that is when it just went into the else loop without printing any value. So in that case we can rule out all these two possibilities. One is our application is not like crashing because we just printed end, it is the user who entered a wrong data, that's it, okay. That is where we can use this else, okay, if you were to check whether this while loop ran or not, okay. Yeah, so that is very much about the while loop. Now let us go for a for loop. Okay, again, as I mentioned, I think I mentioned like twice or thrice, a for loop is a very optimized loop, and even it is very optimized in Python, okay. For this for is optimized in Python, why I was saying it, it is because of the membership operator. Because of the membership operator, this for is very clean and optimized, and it has a very neat syntax, okay, it is very neat and simple syntax. Because of that only, because of the for membership operator. See, just you can like give this for loop syntax, just whatever we talk for this in that, like that only we can simply give, we can simply write a for loop in Python like that. It is very simple, that is why, okay. And yeah, coming to the for loop, coming to the for loop, so it is always used on iterables, okay. We know, I think I have already explained why we use them on iterables, okay. We have already seen this next method and has next method, okay. Yeah, so whatever the sequence which has an iterable sequence implemented, okay, so all those sequences we can use on for loop, okay. If there is any sequence which is not coming from an iterable, it is not advised to use a for loop because we don't really apply a membership operator on them, okay. Yeah. Now the syntax for this is for some variable, you can create any variable name here, okay. These clever codes are they are not needed, okay. I'm just like typing here, you can use any other variable name, Okay. Yeah, this variable name again is a local variable. So we'll see what are the local variables and the global variables whenever we go into the functions. Okay. Yeah, at that time it would make more sense than here. Okay. Yeah, so this variable name is a very local variable. That means local in the sense whenever you go out of this for loop, it doesn't have any lifespan. Okay, so it will create with the start of this for loop, and it will end with the end of this for loop. Okay, and then after this variable name, you will simply use the membership operator in. Okay, and then your iterable sequence. And after the iterable sequence, you will simply give the colon and just enter and write whatever you want to write. So whatever the piece of code that you want to write, you can write inside this for loop. Hey, it is very simple, right? So here we don't have initialization class, we don't have conditional class, we don't have an increment or decrement. All these things are handled by the iterable itself. Okay, that is why I told this for loop in Python is even optimized compared to any other programming language. Here we are not giving any of these three classes. These three classes very necessary if you want to run a for loop, not a for loop, if you want to run any loop. Okay, but all these three are handled by the iterable itself. First, whenever we give something, some variable in iterable, so first it will check whether to initialize or not. That means, so first it will check whether it has next or not. Okay, has next method. So first it will invoke has next method, has next function or the method from the iterable. So if that returns true, that means that is where we are starting the loop. That is, it is indirectly an initialization class. Okay, so once the initialization is done, now we enter into the loop. So this condition is returned to a true. Okay, and then we executed this, and then the iterable itself will check again the has next. Okay, the has next again act as a conditional class here. Okay, in the subsequent checks it acts as a conditional class. Initially it acts as the initialization class, and in the subsequent checks, in the subsequent iterations or the loops, it acts as a conditional class, and it itself is an increment or decremental class. Okay, it will automatically increment by itself. Okay, we don't need to worry about that. Okay, so just because of this iterable feature, so this for loop is very optimized with the help of this has next function inside this iterable. So all these three things are handled very much gracefully without even the user or the developer intervention. Okay, yeah, let me give an example and again like walk you through these iterable functions. Okay, iterable actually is a kind of abstract class, I would say. So it has mostly many methods, but we mostly use has next and next, these two methods. Okay, so because of these two methods, we are able to like achieve this looping thing on these iterables. So whenever we do loopings on these iterables, we call them as iterations. Okay, now I don't call them as loops, I call them as iteration, because for loop is only for iteration. Okay, now I am doing the iteration. I told you, right? So range is an iterable function. The range is a sequence. So now I use the range here. So now I want to print values starting from 1 to 10. Okay, for some variable name var in, I want to print from 1 to 10. That means start is 1 and the end is, so since I want to print 10 as well, just need to give 11. Okay, now print var. Okay, now we just printed 1 2 3 4 5 6 7 8 9 10. This is on a very top level. Excuse me. Okay, now internally what is happening here? As I told you, this range function will create some values called 1 2 3 4 5 6 7 8 9 and 10. Okay, so the inside the sequence, which is an iterable sequence, we have 10 values now. Okay, now whenever I say var in range of 1 to 11, okay, now what happens? So whenever I say this whenever I call this membership operator, first, in the very first beginning, this var is nothing but a simple variable which does not point to any memory. Okay, now what it does is, so internally this iterable sequence, okay, it calls has next method. The first method it will, what it calls is has next. Okay, so first itself it calls has next. So this iterable function has next. That means it will check whether there is at least one value inside this iterable or not. There is one value which is 1, okay, which is true. That means whenever this has next return true, that means our initialization condition is done. Okay, whenever has next is true, now what will happen is, for the var, so it will assign, so it has to assign the value 1, right? So in order to assign this value 1, what method it will call? It will call the next method. Okay, so previously this next method was pointing to the very beginning. Beginning means in every iteration, so the beginning of iterable is some empty space. Okay, so now when I call this next, so it will give some value. Okay, what is the next value? Which is 1. So now the variable will have 1. Okay, so inside the variable memory we have the value 1. Okay, now when I say print var, so now we know how this goes. So first it will go to the reference memory. From there it will fetch the memory location. So in the memory location, what do we have? 1 is stored. Okay, now we printed 1. And then next, again when we come to this particular statement, what it does again is, it again calls the has next. The same step repeats. For the second step, it again calls has next method. So has next method means, so previously we were pointing to 1. So it will check it has any next value or not. So since after 1 also we have the value 2, that means this method will return a true. Okay, so since it returned a true, now what it does is, so for this var, we call this, we assign a value by calling this next method. So what is the next value from 1? Which is 2. So now we have 2 inside the memory location of var, 2 stored inside that. So whenever we call print of var, we just printed 2. So it go on like that. So once we come to the 10th step, okay, in the 10th step, so has next. 10th step is from 9 to 10. Okay, so previously we just printed 9. Okay, so far we printed 9. So in the 10th step, what we are checking, so after 9 also we have some value which is 10. So now this return true. Now it will assign var is equal to, it will call a next method, and whatever the value returned from the next method will be assigned to var, which is 10. Okay, so now whenever we call this print of var, we just printed 10. Now, so far we have printed all the values. Now let us see how this loop is ending very gracefully. Okay, so now how the for loop is, when I say for loop never enters into an infinite loop, how that is being handled here. Now let us see, so far we have printed all the values till 10. Now what will happen in the 11th iteration? So now we are in the 11th iteration. Now whenever in the 11th iteration, so the iterable calls this has next method. Okay, so iterable is a very intelligent sequence. Okay, it knows from where the data is starting until where the data is ending. Okay, so 10 is the very last data. So you are pointing to 10 currently, and after 10 we don't have any value. That is when this has next return false. And whenever this has next method returns a false, so that is a sign for this for loop to end. Okay, so whenever has next output is a false, that means we don't even enter into the we don't even do this particular thing. Okay, we simply come out of this for loop. Okay, it will check, this is the base condition, it will check. If it is false, we don't even do this operation. Okay, it will simply come out of this for loop. That's it. Okay, so this is how the for loop internally acts with the help of this iterable and the membership operator. Okay, yeah, that's it. Any doubts here how the for loop works?
So main difference between while and for loop is iterable, right?
Yes, it is iterable. Yeah. Okay, I'll take that as a no. Yeah, so our very last topic for today is control statements. See, this is a for loop. These are loops and conditions. Okay, so and so are happening. This is a loop, so we are obviously like controlling that loop till the condition satisfies. Okay, whenever this condition satisfies, we are handling that. And so there are a few scenarios. Okay, for certain kind of data, we don't want to do something. Okay, in the loop itself. So here we are printing simply from 1 to 10. So if I were to like only print the values which are not divisible by 2, or not just don't say 2, which are not divisible by 3. So how can I handle that? How can I control this loop? Okay, in such a way that it does not print the multiples of 3. Okay, so how can I control the loop? And at some time, so whenever we encounter some value, okay, and if I don't want to proceed further, how can I do that? These are two things which where we just need to control the loopings. First thing is I would not say values. If you were to like skip a few steps in the loop, okay, so this is the first thing. How can you control this loop in such a way that we can skip a few steps for that particular iteration only? Iteration or loop. Okay, and second one is, so if you encounter such a kind of data so that you don't want to proceed, so in both of these cases, how can you like control the loop? Okay, so for that we have two control keywords, which is like continue, second one is break. Okay, so these are like simultaneously, you can like apply them simultaneously. Okay, so for the first step, if you want to like skip some steps, that means you can use continue. And if you want to like break the loop, that means if you don't want to proceed in the loop itself, you can simply break out of the loop. Okay, so you can simply use this continue and break. So these are simple keywords. So let us go with an example. Okay, so the previous example itself, let us say I'm like looping for a value in range of 1 to 10. Okay, see, now I want to skip 3 multiples. I don't want to print multiples of 3. Previously, what is my for loop? It is simply printing the var. Now what I will do is, so before this printing, if var is perfectly divided by 3, perfectly divided means the remainder is 0. Okay, for to know the remainder, we know how the operator we need to use, which is a modulus operator. If var modulus of 3 equal to 0, that means this is a 3 multiple. In that way, what we need to do, we just need to continue. We don't want to do the further steps. If I say continue, it will simply go to the for loop. It doesn't even go to the it doesn't even perform the further steps. Let us see the output for this. See, I've just printed 1, 2, 4, 5, 7, 8, 10. Okay, now we don't have 3, 6, 9 here. Now let us see what is happening. Okay, for the first value 1, so 1 percentile 3 is 1, which is not equal to 0. That is why 1 is printed. Next 2 also printed. Next 3 percentile 3. Okay, 3 when you divide 3 with 3, the remainder is 0. That means this is satisfied. Now whenever the compiler or the cursor encounters a continue, so it does not perform the statements after this. It will simply go back to the for loop. Okay, we will simply go back to the for loop and do the incrementation. Now the next value is 4, which is printed 4, 5, and for the 6, we simply encounter the continue, and then yeah, like that. Okay, so this is how the continue works. Now how can you break? Now what is the use case? Now, okay, let's say I have a list. Let's say this is my list. Let's say it has A, it has B, it has C, it has D. Okay, no, simple example, Python. Okay, this is not a list. Okay, this is a string. Okay, now I have a string. Okay, Python. Now if I were to check, if I were to print the values till I encounter a vowel. Okay, I just want to print the consonant till I encounter a vowel. So here I have vowel at O. So I just wanted to print P by PH. I don't want to print O and N. How can I do that? I'll simply run a for loop for each character in the st1. Okay, if char in break, otherwise print the char. Okay, now let me just run without this break. We'll see how this works. When I like ran this loop on this string Python, so it just printed P by PHON every time. Now what is the problem statement that I have given? So I just wanted to print the value, the characters in a string till I encounter a vowel. That means whenever I encounter a vowel, I don't want to do anything. So that is where, so whenever there is an encounter coming, whenever there is a vowel coming in, I just wanted to break the loop. I don't want to do anything. So now what we have printed, we only have printed P by PH. That's it. Since after this O is encountered, so that means this condition is satisfied to true. So this condition is satisfied to true. That means we enter into this if block. So in the if block, what do we have? We have a break. So whenever we encounter a break, this will tell the Python compiler to okay, now I encountered a break, so it is my responsibility to break out of this loop. That means to go out of this loop. Even though there are some statements and even though there are few conditions which satisfy the loop, I don't want to worry about them. I just want to simply go out of this loop. That is what it simply did. It simply go out of the loop whenever it encountered boom. That is when we just only got it P by PH printed. That's it. Okay. Yeah, these are some simple statements, control statements. And there is another control statement. I would not say this is really a control statement, but yeah, this is categorized as a control statement. Okay, so for some block of code, if you don't want to give anything, okay, currently you are in a dilemma to decide what to do. So here, if you are still thinking whether to break the loop or not, so here what you can do is you can simply write a pass now. Okay, here you can simply write a pass now. That means whenever you see a pass, that means something has to be done there. Okay, it is just for the user's purpose. Okay, in case if you don't know currently what to do inside this if, okay, in that case you can simply write a pass. In future, whenever you are like decided what to do inside this if, you can remove this pass and you can use this break or any other logic. Okay, it's simply pass. It doesn't throw any error even though you don't give any values. Okay, but yeah, if you don't give anything, it will simply throw error, because whenever you are starting an indentation, it should have something. Okay, that is where we got this indentation error. Okay, yeah, so this continue. If you want to skip the loop or the iteration for few steps, okay, we use the continue control statement. And if you want to like break out of the loop, then use the break. And if you don't know what to do currently, you can simply use a pass under that indentation level. Okay, yeah, so these are the control statements, and we have seen the for loop, we have seen the while loop, or we have seen the if statements. And I would say you are like very much ready to write any of the code in Python for now. Okay, simple programs I would say. wherein you can like do some iterations and you can do some checks. You can like break out of the loop. You can do something like that. You can do multiple operations, whatever you want to do. Yeah, but yeah, there are some inbuilt functions which we'll see in the later sessions. For today, I think you are very much good to like use a for loop, use a while, use a if, and how can you write a elif ladder, and we have a practice question as well. So we have implemented one problem with the nested if. I just wanted you to like implement same with the elif ladder. Okay, this problem. And also I'll also post a few of the problems in the group. Try to practice them before tomorrow's session. If you have any doubts, yeah, you can ask in the tomorrow session. Okay, so tomorrow we'll go the built-in functions for the numericals strings. Okay, if the time permits, we'll also move to list tuples. Any doubts in the today's session? Can I take it as a yes or a no?
No, sir.
Yeah, it's clear.
Okay. Okay. Yeah, we'll share this document and also share, as mentioned, few problems. Okay. Try to solve them. Yeah. Thank you,
Thanks,
guys.
Mishra.
Thank you. Thank you very much.